Welcome. In this video, I'm going to walk you through integrating a rational function like this using a technique called partial fraction decomposition. Now, partial fraction decomposition, its intent is to basically undo the addition you would have done to get this fraction in the first place. So bear with me if that explanation doesn't make sense quite yet. The first step you want to do is rewrite the denominator, that is factor it. This one factors to x minus 2 times x minus 3. And now I have two distinct linear factors. That is, none of them are twinsies. This is an x minus 2 and an x minus 3, so no twinsies. That means they are distinct. Another thing is they're linear, which means that the exponent on the x is just a 1. It's not a 2, it's not a 5, it's nothing else. It's a 1. So since I have two distinct linear factors, I need two fractions on the right side of my equal sign, and under, that is in the denominator of each of these fractions, I'll have x minus 2 and x minus 3. That is, I'll have the distinct linear factors of the denominator in the denominators here on the right. Now on top, I need just some placeholders. In this case, I used a and b, but you could use any letters you'd like. This can be rewritten equivalently as x minus 4 equals a times x minus 3 plus b times x minus 2. Now, if you don't see how I got this, please pause the video and multiply both sides by x minus 2 times x minus 3. So do that to both sides. That is, you're multiplying both sides of this equation by the common denominator, and you should end up with the same quantity here. As a quick mental shortcut, if you notice, this is the original denominator. There's an x minus 2 here. So that means when I multiply both sides by this quantity boxed on the left, by this expression I have boxed on the left, a should only have the other factor, x minus 3 multiplied next to it, since it already has an x minus 2 on the bottom. And similarly, when I multiply both sides by this expression in the box, b has an x minus 3 in the denominator. So instead, b will end up multiplied to an x minus 2. Okay, so where does this get us? I've rewritten this, and now I'm going to rewrite this one more time, and I'm going to rewrite two equations based on this. The first one involves only the x's, so x equals ax plus bx, and the second involves all the constants, so negative 4 is equal to negative 3a minus 2b. In order for this equation to hold, 1 has to equal a plus b, so a equals 1 minus b. Now I can substitute 1 minus b for the a here to get negative 4 is equal, Now before I substitute 1 minus b in for this a, I notice that all of these values are negative, so I'm going to rewrite this as 4 is equal to 3a plus 2b. And now I can rewrite this again as 4 equals 3 times 1 minus b plus 2b. Now please take a moment, pause your video, and solve this algebraically. So you should have gotten b equals negative 1. That tells us that a is equal to 1 minus negative 1, so a just equals 2. So what have you accomplished here? And please leave space next to your integral when you're writing. So now what have we accomplished here? Well, we've managed to rewrite x minus 4 over x squared minus 5x plus 6. We've rewritten that as 2 over x minus 2 plus negative 1 over x minus 3. That tells me integrating this function is equivalent to integrating both the sum of these rational functions. All right, so now I've rewritten this here as part of this integral, and I'm going to split this as two integrals. You do not have to do this. You can go ahead and integrate directly from here. Now, if these integrals here do not seem straightforward to you, please look at the videos that should be popping up kind of in this corner of the screen right now. It's a little link to another YouTube video I made showing you how to integrate functions that look just like both of these. This becomes 2 times the natural log of x minus 2 minus the natural log of x minus 3 plus a constant c. And the crux of these problems is really the partial fraction decomposition. The calculus isn't really hard, so if you're at all rusty on this topic, please spend some time Googling partial fraction decomposition. Right now, this example is still the case of distinct linear factors. I hope this video, along with the algebra explanations that correspond to the calculus, have been useful to you.